Have you ever wondered what it really takes to pull off a graduate-level technical project? It's so much more than just writing a long paper. It's a whole journey, really, from a single, simple question to a full-blown thesis. So let's break down the anatomy of that journey. It all kicks off with this one number, 600. That's how many hours a student is expected to pour into their master's project. To put that in perspective, that's like working a full-time 40-hour-a-week job for almost 4 months straight. Yeah, this is not just another assignment. We're talking a serious commitment. You know, the University of Hertfordshire's own project handbook puts it perfectly. This isn't about just following a recipe. No, it's about being in the driver's seat, figuring out the challenges, and creating something totally new, all on your own. So you might be thinking, how on earth do you even start a 600-hour challenge like this? Well, thankfully, it's not a total free-for-all. It actually starts with a really clear, structured path, a set of milestones that guide you from that first spark of an idea all the way to the final thesis. And here is that roadmap, pulled straight from the handbook. There are 3 big checkpoints. First up, the detailed project proposal. That's where you lay out your big plan. Then you've got the interim progress report, which is like a crucial halfway check-in. And finally, the grand finale, the final report and viva, where you show everyone what you found and defend your work. Okay, let's talk about the first step, which is honestly maybe the most important part of the whole thing. Finding a good question. This is the creative spark. Every single great project begins with someone getting really curious about a problem that needs solving. And the questions students come up with are just incredible. They're all over the place. On one side, you have people exploring the human body, asking things like, can we use muscle signals to tell if someone's tired? And does that tiredness mess with how well a prosthetic arm works? Then, on the complete other side of the spectrum, you've got students in the digital world asking, how much does a simple smiley face really change what an algorithm thinks a tweet means? All right, so you've got your question. Now what? Well, you need the right tools to find the answer. This is where all the technical know-how comes into play. Students have to put together a very specific toolkit of methods and algorithms that are just right for their project. And for a ton of these projects, the star player in that toolkit is machine learning. Just think of it like teaching a computer to spot patterns in data all by itself, whether those patterns are in muscle signals, weird network traffic, or just a bunch of tweets. It's the engine that makes so much of this research go. But hold on, it's not always just about a fancy algorithm. Some of these projects are just massive engineering feats. I mean, look at this. This student designed and built an entire software system from the ground up just to help other students work together better. That's incredible. And this just shows you how specialized these toolkits get. If you're looking at muscle signals, bam, you're probably using something called a convolutional neural network. Trying to spot hackers, you might mix a decision tree with a support vector machine. And for predicting something like food production, a classic like linear regression might be perfect. See? It's all about picking the absolute best tool for your specific job. So you've got your question, you've got your tools. Now comes the real test, the experiments. This is the crucible where theory smacks right into practice. It's when you run your models, test your code, and basically let the data do the talking. And sometimes the data speaks loud and clear. Take a look. The students studying muscle fatigue tested their model on fresh muscles versus tired ones. And the results? A really significant drop in accuracy, from over 85% down to about 79%. Boom. Hypothesis confirmed, fatigue really does matter. And check this one out. This is a huge win. A student came up with a totally new way to spot malicious stuff on a network. When they put their method head-to-head with the established ways of doing it, theirs achieved a staggering 99.77% accuracy. It didn't just work, it worked better. That's innovation right there. But research is rarely a straight line. It's messy, and sometimes the most fascinating results are the ones you never saw coming. As this student found out, sometimes an experiment that fails can teach you way more than one that succeeds. This story is just fantastic. So this student figured, okay, I'll apply a filter to get rid of all the electrical noise in my data. That should make things better. But what happened? The accuracy actually went down. It turns out the noise they were trying to remove was actually the valuable data. What looked like a failure was actually this profound discovery about what was really going on. So, after all those hundreds of hours, all those experiments, the successes, the surprises, what's the payoff? What's it all for? Well, This is where all that hard work gets turned into real insights and hopefully real-world impact. Sometimes that impact can be summed up in one really powerful number. That 99.77%, that's not just a good grade on a project. It represents a real step forward in cybersecurity, something with genuine, real-world applications that could help protect all of us. And that whole journey, from the first little curious question all the way to those final impactful results, it gets carefully documented in the final report. This structure isn't random. It's a logical flow that tells the complete story of the project from start to finish. But it's so important to remember that behind every report, every line of code, every single data point, there's a person. This quote from a student's acknowledgments, it's just a great reminder that these huge technical projects are also deeply human projects, made possible by the support of family and friends. So in the end, a project like this is kind of a cycle. You start with one question, and by the time you've answered it, you've probably discovered 10 more you want to ask. And that, right there, is the engine of discovery. So it leaves you with one final thought. If you had 600 hours to dig into anything you wanted, what question would you ask?